All right, so the standard normal distribution, what is that and where did it come from and why am I talking about it? So the standard normal distribution is a specific normal distribution where the mean is 0 and the standard deviation is 1. Okay, so there's a little formula here, and I'll just highlight it for a second. It's this little formula right here. This you need to know. And it's a way to convert from any x that's a normally distributed function with a mean and a standard deviation to a z value. Now this is more important to people that don't have calculators. You guys have a calculator, you can do it on the calculator. So the conversion between a normal distribution and a standard normal distribution is not as necessary today as it was, pre-calculator, whenever that was. But what happens in terms of finding the probability with a z distribution is we can figure out what the actual probabilities are for one standard distribution, and then we create what are called z tables or normal distribution tables. And if you know the mean and standard deviation, you converted the x value that you're looking for into a normal z score by subtracting the mean and divided by the standard deviation, and then you look up that z score in the z table. Now the good news for you guys is you don't have to do that anymore. You don't have to know how to use a standard normal distribution table. So we're not going to spend a lot of time on that particular aspect of it, but just to understand, this is the conversion. Z is equal to x minus mu over sigma. So if you're given a question to find a particular probability, you can do it with a z distribution by just, when you're on your calculator, and I mentioned this in the previous video, when you go into your menu and ask it to do actually just a second, I better make sure that I'm down here. I am, okay. So menu, statistics, distributions, and normal CDF, you'll say it's less than or equal to 1.2. Let's say we just do that one just to show you. You see how it's defaulting to 0 and 1, you just leave those alone. So you just type in 1.2, you leave this, that's your negative infinity, and you just hit OK. So you can find a z score just by leaving the mean as 0 and the standard deviation as 1 on your calculator, and it defaults to that. And so you can do a bunch of these, you don't have to. All right? Now, in order to do this with, using this formula, what happens is you can figure out what the probability is of an x value by figuring out what the probability is for a z value. Now again, you don't have to use the standard normal tables. They're actually not even printed in the formula booklet anymore. But if you want to convert, you have to just take this little formula. This says the probability is x is less than or equal to 69, where the mean 62 and the standard deviation is 7. So what we're going to do is we're going to convert the 69 by subtracting 62, which is 7, right? 69 minus 62, I think it's here. It is, and then, divide by 7. So you end up with a z score being less than or equal to 1. And then on your calculator, you can just, oops, sorry, that's the wrong icon. You can just take your normal CDF now, that's all set up as 0 and 1, and just change this top range to 1. So you're going to go from negative infinity up to 1. Your mean and standard deviation are 0 and 1, and you get 84%. Which is our answer. Now, the sort of question you might be wondering is, why would I care to do that if I already know the mean and standard deviation? Because I could just do this, right? I could just take my normal CDF and go with the x value. So we know the x value that we're looking for is 69. We know that the mean is 62 and the standard deviation is 7. And if you hit enter there, you will get the exact same number. So with the advent of technology, there is no reason to do the Z table anymore. But it's still important you understand how to convert from X to Z. And the reason that it becomes more important is actually because of the inverse normal functionality. So you can do these. It says to convert to a standard normal and then do it. We're not going to spend a lot of time doing that. What is interesting is, how do I find the x value that's associated with a particular probability? So here, you see it says, what is it with the 95% probability, the longest snail shell length, if you have a mean of 23.6 and a standard deviation of 3.1. So that gets us to a different functionality. All right. On your calculator, if you go into the menu and go to statistics and distributions, chi-squared, let's see, distributions. If you look here, there's an inverse normal. Okay, and the inverse normal function, we use that when we have the probability and we're looking for the x value or the z value. So we're going to take our area, which in this case is 0.95, and if we just hit enter now, it's going to give us a z value. So if you look at this solution, it's going to give you a z value, all right? But you can also just put the standard deviation and the mean in here. So if you know the mean, this one already tells us the mean is 23.6. So we put in 23.6, and the standard deviation is 3.1, and we hit OK. All right, and it just gives it to us. It's 28.699, so 28.7 basically. And we get the same answer. Either using this method or the other method. This is a different example, just so you're clear. We're not getting that number because it's not the same number. But if you look at this example, this one says the mean 70, the standard deviation is 10. So if you go back to your calculator, if you want to actually get that number, you just go inverse normal 0.95, the mean 70. So you type in 70, the standard deviation is 10, and you just hit enter, and you get your 86.44, which is what they have down here. All right, so you can use your graphing calculator to find the inverse normal, and you should. Okay, it's just a matter of taking the inverse normal of the probability and finding either the z value or the x value. Now, sometimes the usefulness of this, and I don't know if I have an example here or not. I don't see one there. No, I don't see one there either. There are examples, and we'll do some of them. I don't see any ones right here. But where you are actually asked to find the mean or the standard deviation, and if you're asked to find one of those two things based on a particular x value having a particular probability, that's where you use z equals x minus mu over sigma. All right. Here's an example. There we go. So let's just go through this one and then we'll end the video. But it says the height of certain flowers have a normal distribution, and they know that 20% of them have less than 3 centimeters of height and 10% have a greater than 8. So what we're going to do, we don't know the mean and standard deviation. So we're going to do an inverse normal of those two probabilities. Okay, on your calculator, you're going to go inverse normal, but you're going to use 0 and 1 because you don't know. So 20%, we're going to go 0.2. And it says, just to note, you see what it says? It says they have a height less. So we're going to leave that as less. All right, mean of 0, standard deviation of 1. What ends up with the second one happening is you get 10% that have a greater than 8. When you're doing inverse normal, it always has to be less than. So we have to convert it to 0.9, okay? So we're going to go inverse normal, but our probability is not 0.1, it's 0.9 because it's the less than probability, and we get 1.281. So that's where I'm getting these z values from. Once you have them, they're associated with particular x values. So then you take your formula, and you actually end up having to solve for sigma and for mu. So you actually go x is 8, z is 1.28, x is 3, z is negative 0.842. And you solve this system of equations. So you can actually do that on your calculator as well if you want to, or you can solve it by substitution. Okay? But what we end up with is a linear equation, a system of linear equations. It's either substitution, all right? So the substitution is going to give us these two values. And I apologize for the announcements coming over, but I can't control that. So hopefully you can still hear me. But you basically end up with a linear relation with x and y, except it's sigma and mu, and you just solve it. All right, so that's where we're going to end the video. Hopefully that makes sense to you, and we're going to do some more practice in